One of the questions I should say that we'll be considering in this lesson is question number 8. Now this question comes from a BGCSE Mathematics past paper, and this is a past paper, paper 2. Okay, so the questions I will be considering for this lesson comes from a paper 2 Mathematics BGCSE examination. Okay, so let's get right into question number 8. Question number 8 states the following. A holding tank A has a length of 20 feet, a width of 15 feet, and a height of 9 feet. Another holding tank B has a square base and a height of 12 feet. Both tanks hold the same quantity of quantity of a liquid when full. So here we have holding tank A, and notice that holding tank A has a length of 20 feet, as stated in the question. It has a width of 15 feet, as stated in the question, and it has a height of 9 feet. Now we have another holding tank B, and it has a square base, a height of 12 feet. So the height is 12 feet, and its base, its bottom, okay, is a square base, a square bottom. Now notice that the length of this holding tank, we don't know. There's no value given. And the width of this holding tank, we do not know. There's no numerical value given. And since we don't know exactly or precisely what the length or the width is, we're going to use a variable or a letter to represent what that number is. And the letter that is used here is x. And x represents a number. X is saying that, hey, we don't know what the number is, but let's use a letter to represent that number. And since it's the same letter that is used, that means that the length and the width is equal to each other. And that should be that's right, because the reason why that's right and that makes sense is because we're dealing with a square base. And so that means that the width and the length are the same because it's a square base. The bottom is a square, and the thing about the thing about squares is that all the sides on the square is equal. And so if the length is x, the width must also be x. But the height of this square, the height of this entity, the height of this 3D shape is 12 feet. And note that both tanks hold the same quantity of fluid when full. So in light of all the information we discussed, they want us to calculate the volume of the holding tank A when full. So let's consider that question. So A says, determine or calculate the volume of the holding tank A when full. Now, in order to do this, we must use a formula, okay? And so the volume, okay, the volume of holding tank, volume of holding tank A So volume of holding tank A, notice that we're going to use a formula for this in order to determine the answer. So volume of holding tank A when full is going to be equal to the length of the holding tank multiplied by the width of the holding tank multiplied by the height of the holding tank. Now the length of the holding tank, as stated in the question, is 20 feet. And as we can see in the diagram, is 20 feet. That's the length of the holding tank. So 20 feet. But what is the width now? What is the width of the holding tank? That information we can get from the question, it says that the width of the holding tank is 15 feet, as we can see in the diagram. So that's 15 feet. 15 feet. And the height of the holding tank, is 9 feet, as we can see in the question. Sorry, in the diagram. 9 feet. And so in order to find the volume of this holding tank, I must multiply 20 by 15 and by 9. And so that's going to be equal to, so let's use a calculator to determine that answer. 20 multiplied by 15 multiplied by 9. Now calculators are permitted in the BGCSE exam. So that means we can use it here. So 20, that dot represents the multiplication symbol. So that's 20 multiplied by 15 multiplied by 9. And so once we calculate it, the answer that we get is 2,700. 2,700. And so the answer here is going to be 2,700 feet. But notice, right? Notice that there are, if we look at the question, we rewrote feet 3 times. We wrote feet 3 times. What do I mean? Notice that we have feet here, and feet here. And so what we're going to do in our answer is say that it is 2,700 feet cubed. Feet cubed. And so the correct answer to this question, or we can say the volume of the holding tank A when full, is 2,700 feet cubed. Okay, with that understanding, let's continue on to question B. Question B. Now, if we look at question B says the base length X of the holding tank B. So they want us to calculate what is the base length X of the holding tank B. So this is the length here, okay? So what is the value for X? We don't have a numerical value for X, and they want us to determine the value for X. Okay, so what information do we know? Notice that, let's look back at the question. So let's grab this, and I'm going to crop this image and insert part B for us. Okay, so all we need is part B. And they want us to determine the base length X of the holding tank B. So how are we going to do this? Okay, so let's do this. Notice that they gave us a very important hint. They said that both tanks hold the same quantity of liquid when full. And so the same amount of liquid that holding tank A would take up, or would hold rather, when it's full, is the same amount of liquid that holding tank B would hold when it's full. And so what that means is that the volume, okay, so the volume of holding tank A is equal to the volume of holding tank holding tank B. Okay, and so this equation is going to be very useful for us as we consider this question. Or said differently, okay, said differently, we can say it differently. We can say that the volume of holding tank B, okay, is equal to the volume of holding tank A, okay? And I prefer to write it in this way because when we're working it out, it's going to because when we work it out, it it looks better aesthetically when we have it like this. But saying volume of holding tank A first equals the volume of holding tank B is the same. It works. It's fine. I prefer to have it oriented like this for aesthetics purposes. Okay. All right. So let's work with this equation. So we said that the volume of holding tank A, sorry, B rather, the volume of holding tank B is going to be equal to the volume of holding tank, the volume of holding tank A. Now, what is the volume of holding tank A? Now, we saw, based on our last question, the volume of holding tank A is 2,700 feet cube. And we know that the volume of holding tank B, based on the formula, is going to be length times width times height. Now, if we go to volume tank B, we saw that the height is 12 feet. Okay, so that's 12. We saw that the width is x feet. And we saw that the length is also x feet. And so that's x. Okay, and so that's going to be equal to 2,700. Now, what is x multiplied by x? Well, x multiplied by x is definitely going to be x squared. This is multiplied by 12, and it's going to be equal to 2,700. Now, x squared times 12, x squared times 12 is 12 x squared. That's going to be equal to 2,700. Now, we want to isolate the x squared. So we want x squared by itself and everything else on the other side. And so with that being said, we want to divide both sides by 12. And divide both sides by 12. And so that leaves us with x squared equals to, well, what is 2,700? Okay, what is 2,700 divided by 12? Let's use a calculator to determine that. 2,700 divided by 12. So 2,700, I'm going to divide that by 12. What is our answer? 225. So x squared is equal to 2,700 divided by 12. And so that's going to be equal to 225. So x squared equals to 225. Now the goal the goal that we have is we want to solve for x. We don't want to solve for x squared. We want to solve for x. And so the question is, how can we remove, what can we do to remove the x, that's the square, that 2 on top, okay? What can we do to cancel out that 2 on top, okay? But in order to cancel out that 2 on top, okay, in order to remove that x squared, what we need to do, and this is what you do in order to remove that square on top, we need to take the square root of both sides of the equation. So we need to take the square root of both sides of the equation. And the reason why that's going to work is because this squared is going to be canceled out by the square root. And so we are left with simply x, just like we wanted. But what is the square root of 225? Well, the square root of 225, let's go to our calculator. The square root of 225, square root of 225. What is the square root of 225? Well, that's equal to 15. That's equal to 15. So the square root of 225 is 15. And so that means that x is equal to 15. I should remark that this holds true, this equation holds true if x is greater than 0. So we're going to put x is greater than 0. Okay? And so this is going to work for x greater than 0. So where x is a positive value. Okay? And the reason why I made that remark for x greater than 0, I'm saying that this equation right here, that x is going to be equal to the positive square root of 225, and that x is equal to 15, is because, to be honest, when we take the square root of both sides, what we really supposed to do, okay, what we're really supposed to do is we're supposed to do positive and minus, okay? And then x supposed to be positive or minus. But because length cannot be negative, like we cannot have a negative length, not in real life, okay? Length could be equal to 0 or greater than 0, but length cannot be negative. And so that means that for our answer, we only need to be considering positive values. And so that's why here I do not include the negative, because we only considering positive values. However, from a math perspective, if we want to be specific and technical, we're saying that, hey, this equation only is true if our value of x is greater than 0, or only for positive values of x. And for positive values of x, if we know for sure that x is positive, then we don't have to consider the negative option. And so our answer is x is equal to positive 15. And so that means that the base length, right, the base length of x, okay, the base length of x is 15 feet. And so this is 15 feet. And since we're dealing with a square base, if this is 15 feet, this must also be 15 feet, because the length and the width is the same. Okay? All right. So let's see how much time we have. 19 minutes. Okay, that's the end of this video, and I'll see you on the other side of, or I should say, I'll see you in a next lesson. Thank you for watching.